Okay, everyone, let's do another video. This is my obviously number 6 video in my little series on IM3 first semester review. Here we go. So here now we're talking about actual graphing of polynomials. And the key thing to always remember is the highest power is going to pretty much clue you in on what the overall shape of the graph is going to be. So we're all familiar with x squared being a parabola shape. So notice the right and the left sides go up, right? Of course, if it was a negative x squared, it would open down like so. Well, the one thing to understand is that any even-powered function is going to react at the ends the same way. So in our case here, because it's a negative 4x4, we know it's going to open down just like a negative x squared. Now, the middle of the parabola is going to have maybe some humps, some wiggles, or whatever in there. But the left and the right sides of that graph is going to open down. So if we go through our answers here, rises, nope, it's not going to rise anywhere at the ends anyways. So we would say it falls to the left and falls to the right. In other words, it's going to open down like this, like this. Again, in the middle, it could wiggle up and down and have humps here or there. But we know the left and right ends are going to open down. Okay? Now, odd functions work obviously differently. With odd functions, for example, if I had an x cubed, you ought to know it kind of wiggles like a snake like that. In other words, the right end goes up, the left end goes down. If we had a negative x cubed, you see, it would flip and go the opposite way. The left side up, the right side down. And this applies for any odd-powered polynomial function graph. So, if we look at 24, we notice that we have a negative 3x3 there. And because it's a negative, we know it's the same thing as this negative x cubed function. In other words, the left is going to open up, the right is going to fall down. So if we look at our choices, rise to the left, fall to the right, the answer would be A. Now look at number 25. Looks a little different, right? Well, basically, I have one factor there, another factor there, and I have 3 factors there. In other words, isn't that really x plus 5, x plus 5, x plus 5? That's what that cube means, right? So if you agree I have 5 factors, if I multiply this all together, would it not be an x to the 5th power of some sort? Again, because it's odd, we notice like the x3 over here, it's going to open, and it is positive, so it's going to open on the right side up, it's going to go down on the left. So fall to the left, rise to the right, that's got to be the right answer. Again, left side is down, right side is up. All right, one more of these. So this one, notice we have an x squared there. Notice the negative. We have also another factor here, another factor there. 1, 1 plus 2 means if I multiply this together, I will get an x4 and something, right? Now, there is a negative in front. So, again, just like the negative x squared, I know it's going to go down on both ends. So, that's why, believe it or not, it's answer A again. Falls to the left, falls to the right. So, pause the video if you need to. Okay, let's continue on. Here we go. So, on this problem here, guys, again, I'm glad I put a few more of these. On a previous video, I only did one of these difference of squares. Does everyone agree 9x squared is really a 3x that's being squared? And the 16 is really a 4 that's being squared. What we have is a difference of 2 squares. And the way we factor is real simple. If I take 3x with a 4 and I do a plus, times that with 3x and a minus 4, I have it factored. So as you can see, the answer, believe it or not, is A again. And that's how you do a difference of squares. It has to have a plus, it has to have a minus. Pause the video if you need to. Okay, take a look at this one right here, guys. Now, hopefully you recognize the 2, the 12, and 54 all have a factor of 2. So the first thing I'm going to do is do a GCF, as we call it, greatest common factor of 2. So I'm dividing out a 2, factor of 2, 54 divided by 2 is 27. Now, what I have left in parentheses, I can factor our normal way, as I refer to it, or FOIL backwards. So the 2 is there, but it's not going to factor in this part here. We know y times y is y squared. We know 3 times 9 is 27. How do we get a 6y is a 9 minus 3, right? And notice minus 3 times 9 is minus 27. Everything worked out perfectly, so that's why the answer is A again. Okay? Again, we want to make sure there's a minus 3 and a plus 9, and of course a factor GCF of 2 in front, which we have there. And so that's why the answer is A. Pause the video. Okay, and I think we'll make this the last one. I don't think I added one more. There we go. So this will be our last one, guys. Again, I hope you notice that there's only 2 terms here. We're missing that middle term in the middle here. Let's see if they're perfect squares. Isn't 16x squared really a 4x that's squared? Isn't the 25y squared really a 5y that's squared? So notice we have a difference of 2 squares again. And so we're just going to take 4x and 5y and do a plus with them. And then 4x minus 5y. That's how you factor these. And so our answer this time, believe it or not, is A once again. On these kind of multiple choice, guys, watch your signs. Notice how they just kept the signs the same there. Here, I'm not sure. Oh, they basically cut 16 in half. Don't let it trick you, okay, guys? But if there's one thing you learned from this video, hopefully, is that you got to know your difference of squares. On this one, always try to do greatest common factor first. It makes your life a lot easier. And of course, you got to understand the basic properties or end behavior, as we call it, of any polynomial graph. See you next time.